Okay, so we're actually going to start 4.2 today. I don't have my regular markers, so I've got this pen that I'm hoping is going to be okay. I do want to say that from now until exam 3, I mean, it's about a month, about almost-ish, we're going to do quizzes every day. Okay, so before you leave, like the last 5 minutes, you're going to do this quiz with your notes, with everything in front of you. It's going to count for your attendance, and it's going to put quiz grades into the grade book. I mean, it's technically a completion grade. I'm not going to go through there and like grade all. That's just extra work. You know what I mean? But I'm going to look at all of them, make sure there's work on the page, and hopefully your answer is correct because you have your notes in front of you to do it. You know what I mean? But this could just be super tricky. So I'd like to think that doing the quizzes every day, just practicing, of course, would hopefully help you like remember it and how to solve these problems. With these problems, we will not use a calculator. Later, we will need to use a calculator, but for now, like if you do see something and it says to evaluate it and it says not to use a calculator, on your homework, you're at home, you're alone. Like if you know how to do it or how to get to the answer, that's fine. I'm not there. But on your exam, if it says evaluate, show all work, no calculator, there's certain steps that, of course, I would be looking for, okay? So let's go get started. So this is 4.2. Yep, nope. When? That means these are probably going to be light too. Do you have a black one? I have a black one. Yes. Yes. Just something. Let's see if we can get it to light. I was like, yep, nope. Okay, so 4.2, it's logarithms. So like I said, quizzes every day, y'all. Okay. And we'll just do them like right before you leave. So say you have something and it tells you to find inverse of f of x equals 2 to the x. So that's an exponential form, right? That's an exponential function. That's what we've seen before. The way that we find inverses is the same way we would find inverses the first time it was taught, which is switch and solve, right? What we did was we wrote our f of x as y equal 2 to the x, right? Just kind of rewriting it. And y'all, from here on out, this is more of the form that you'll see. Actually, they're going to use like B's and A's, and there's all different kinds of things. But this f of x, like we just won't really see this. Not right here, we won't. So what we do is we switch and we solve, right? So we would switch our x for our y, and we would switch our y for our x. And then now we would solve for y, right? But mathematically, solving for y would mean I would need to get this y out of the exponent, right? And we actually don't have anything to do that. So I think I just wrote need a way to find inverse, we use logs. So technically we could just say cannot solve without a log. That's why there are logarithms, so that we can actually solve certain problems. And I'm going to go ahead and write down what both of these are. Like that. Exponential and logarithmic. I write big, y'all. It's exponential form and logarithmic form, okay? Got two different forms right here. I'm going to write them right here. Okay, so that exponential form, right? We saw it. Don't write what we wrote last time. It was like f of x equals, and we did like b to the x, right? So here, what we're going to do is we're actually going to write it. Of course, the equal sign means they could be written either way, right? So if you look in your book or on the homework, it's b to the x equals a. So it's still in the exponential form, but right here we have an a, okay? For our logarithmic form, we have log, and then it's like a little b, base b, log base b of A equals X. So that left-hand side and that right-hand side, like this is the same thing as saying this. And this is the same thing as saying this, okay? What you're gonna do for the 4.1 homework is we're actually gonna change the form. We're gonna be given something that looks like this, and we're gonna change it into this form and then go from here to here, okay? The actual individual steps are not hard, but like, I just think sometimes simple things are hard, you know what I mean? Or you kind of overcomplicate them. So just make sure that you pay like really close attention, not play it, but pay close attention. I think I have room here. Let's change form. We're gonna go from exponential form to logarithmic form. Okay, so say what we have is 5 equals 2 to the x. I only had this black pen, y'all. Okay, I wish I could do different colors, but I did forget all of my markers. This is in exponential form. I know that because there's that exponent right here, right? If it was in logarithmic form, I would see the word log. But I mean, it's even telling me to switch or like convert it, like change it to the logarithm form. So what I'm gonna do is underneath this, I'm gonna identify my A, my B, and my X. And you notice how it's written kind of in a different way, right? Which, I mean, that's fine. That equal sign means we can do that. But this is saying that my A is 5, right? Equal BX. That's that form. It's just written that way. So I have my A is 5, my B is 2, my X is X. Right? Now it wants me to write it in logarithmic form. So literally, I mean, you can do a little arrow if you want. We've got log. The form says it's the little bitty b, right? So it's log base b. My b is 2. Make sure, especially on exams, that all of like the size of your values or like your terms, that they're not all the same size. If it's meant to be an exponent, like it's supposed to be little and up top, right? This is a subscript, it should be down below and it should be small. It makes the whole answer wrong if it's not written correctly, okay? And it says then this is our A. My A is 5 equals my X. That's my exponent, and it just happens to be X, so it's just X. So if you look at the exponential form, this is saying that I have something raised to an exponent, and then I get a number as an answer, right? A is a number, we just don't know what it is, but if you look at the logarithmic form, this is saying that my answer is my exponent, okay? But you literally just identify what your different parts are and then rewrite it in your new form. We'll actually evaluate some of them and then it'll make a little bit more sense than just this, okay? So let's do this second example. Say we have 5 and it's being squared equals X. And they want us to write that in logarithmic form. I'm going to identify all my different parts. You don't have to do this every time. You could just have the form written up top and just kind of look at it. But I think to keep from getting confused, I know that this is exponential form. I'm changing it to logarithmic form. If we want, we can go ahead and write base b of a equal x. So I do log, my b is 5. My a is x equal, I need my x, which in exponential form, that's the exponent, right? So 2. That makes sense? Now it's literally just like changing it, and we're gonna do some evaluations. We're gonna move towards putting them into equations and solving them, condensing them and expanding them, and like they'll be more mathy then. Right now it's just kind of changing forms. I do have a third problem here. I've got b cubed equals 64, and I'm gonna change it into logarithmic form. So I'm going to go ahead just because, you know, continuity, and I think it's helpful. B to the x equals a, right? Logarithmic form, I've got log base b, which my b is b. And then we have an a right here. Y'all, that b is going to be little, right? But that a is just like a normal, right? And my a, that doesn't really look like an a right there, but that's an a, y'all. My a is 64 equals, the answer to a logarithmic problem is the exponent. So what's my exponent here? My exponent would be 3, right? X, my x is 3. Does that make sense? Yeah, just literally, this video would be recorded, so you don't have to take pictures or record it. You could just watch it on YouTube later. Okay, so that was changing from exponential form to logarithmic form, right? Now let's go the other way with it. Let's go something starting with a logarithmic form and then changing it into exponential form. So logarithmic form to exponential form. Goodness gracious. I'm going to go and write the two forms, okay? I know that if I have b to the x equals a, that's exponential form. And then log base b of a equals x, that's a logarithmic form. And here are my problems. I have log base 3 of 7 equals y. So, I mean, honestly, if it tells me to change forms and there's not the word log written, then you're changing it to a logarithmic form, right? If there is the word log written, you're going into the exponential form. So as far as what form you're changing to, that shouldn't be too hard to see. So b to the x equals a is what I want, right? 3 is my b. And then my a is 7. My x is y. I want the x first and then 7. And y'all, these are saying the same thing. This is saying 3 to the I don't know what power equals 7. And this is saying 3 to the y power equals 7. Okay, after a while, you kind of start seeing little patterns. Oops, let's do this one. Where am I at? 2 equals. So I'm writing it in logarithmic form, but I just kind of have it like switched in a way. Log base x of 64. So looking at this, y'all, my x is 2. My b is x. And my a is 64, right? Okay. So, and this is why I've said that. I'll go and write the log base b of a equals x. So x is 2. My b is x. My a is 64. So writing it in b to the x equals a, b is the variable x. And then my exponent is my x. And in logarithmic form, that's the answer. So it's 2 equal. And then my a comes from right here. And in logarithmic form, there's my a, and it's 64. So write down the general form of the one you're looking at, right? That's this. It's a very general form of the one you're looking at underneath what you're looking at. And then you can tell x equals 2, b equals x, and a equals 64. Using this and knowing that I'm going to this, you then find, well, I need my x, I need my a, and you're just rewriting it, okay? Does that make sense, y'all? Let's do this one. Log base 7 of x equals 3. Go into exponential form. Okay, so I need b to the x equals a. The base is my b, which is 7. And then the answer to a logarithmic problem right here, this form, is the exponent, which is 3. And then my a is x. So literally those are the answers on your homework. It'll tell you which form to change it into. Some problems, like say you're actually going to enter this in as a problem, you do type like the equal sign. You know what I mean? So it's the whole thing. You're going from this way to logarithmic form. Then like there's that actual special keyboard, which would have the word log, right? And when you do that, it will open up the little subscript right here to type in your 7. Then you'd scoot out of that to be able to just like type your x. the actual equal sign and then 3. There's a few problems where it already has the equal sign and it wants you like, what's the left-hand side? What's the right-hand side? So that's really the only thing that I saw. Okay, so now what we're going to do is actually evaluate some of them. And when something says to evaluate it, it means to actually solve it, right? Now, and then after that, we'll look at the properties, which will really help later on with the equations. And then y'all can take this quiz. When you're done, you leave and you get your exam if you want it. Okay, evaluating a log. This is where those exponent rules come into play. Okay, so really understanding those is going to be very helpful in pretty much all of chapter 4, honestly. Okay, so for problem 1, say we have log base 2 of 16 equals, I don't know what it equals. That's what I'm finding out. I don't know if y'all heard me last time, but remember I was like, that exponential form is like b to the something power equals this, right? And logarithmic form, it's 2 to the what power equals 16, right? But until you can really like do that without putting much work into it, I recommend let's write this in exponential form, and then it'll be a lot clearer what we're doing. So if this is log base b of a equals x, and my exponential form is b of x equals a, do you notice how I don't have my x right here? That exponent, I don't have that because literally that's what I'm finding. But once you put it in this form, it's a lot easier to see now. 2 to the 4th power is 16, right? That's because exponential form is saying this base raised to this exponent gives me this answer, right? My answer is a number, right? Over here in logarithmic form, it's our base, right? Our answer though is the exponent. So it's the base raised to this exponent gives you this answer, okay? So that's why we can write them in both different ways, and we can use them to help solve each other. Okay, let's do this one. Got like 6 of these, y'all. Okay, log base 3 of 27 equals. This is saying 3 raised to what power equals 27? It's cubed, right? 3 times 3 is 9. No, 3 times 1 is 3. 3 times 2 is 9. And then 9 times 3 is 27. So you just get a little cubed right there. So I didn't really look at the homework that much, but here they would want the answer, right? I'm saying this is going to be an easier way to get your answer than to try to look at right here and figure it out that way. Okay, for problem 3, log base 3 of 3 equals what? So this is my B, right? There's my A. I'm looking for my X. So here's my B. I'm looking for my X. There's my A. Y'all, 3 raised to the what power equals 3? It's just 1. And this is actually going to be a property that we do in a minute, okay? Because this is saying 3 raised to 3 gives you 3. 3 raised to 3 gives you 27. 2 raised to 4. Do you see what I'm saying? Okay. Your answer in logarithmic form is your exponent. Okay. So let's do this 4th one. Okay. Say we have log base 7 of 1 over 49. Oh, sorry. This is saying 7 raised to the what power gives you 1 over 49. Well, I'm starting with a big number and I'm changing it to a fraction, right? A big number, you know what I mean? Like just a constant. And I'm changing it to a fraction. And so that's where these exponent rules come into play. Do y'all remember the exponent that stated if you had something raised to the negative m power, if it's not in fractional form, put it in fractional form. And moving from like the numerator position to the denominator position changed your exponent to be positive. 7, Colin said -2, right? That's a negative exponent. So what I want to do is actually change it to a positive exponent. And the only way you can do that, if it's written not in a fractional form, write it in a fractional form, bringing it down to the bottom. 7 times 7 is 49. Okay. So this is saying 7 to the -2 power would give you 49, because that's going to bring that 7 down to the denominator. Now it's a +2. You get a +49. Does that make sense, y'all? Yeah, kind of, sort of. Okay. Log base 25 of 5 is what? This is saying 25 raised to what power gives you 5? Do y'all remember the power rule? Not the power rule, sorry. I mean, it is, but whatever. The rule that we learned that stated if you have something raised to a power that's in fractional form, what you do, your denominator is your root, your numerator is your exponent. So an example of this, using the problem we're on right now, if I have 25 and I raise it to the half power, my n is my root, right? So wouldn't I be taking the square root of 25? Y'all, if that's a 3 or a 4, you do have to write it here, right? But if there's not a number here, it's implied that it's 2. It's a square root. What do I get when I take the square root of 25? 5? 25 raised to what power gives you 5? Right. 25 raised to the 1/2 power, to the half power, actually, not 1/2. 25 raised to the half power, 1/2, would give you 5. And that's because I can use that exponent rule, right? And I end up taking the root of it. Let's do this one so you can see. How did I write it? Log base 27 of 3 equals what? So this is saying 27 raised to what power gives me 3? Now, I do know that if you look at the first problem we did with the 25 and the 5, I know that if I, squared 5, I got to 25, right? So that's kind of a train of thought that you could think of as far as like what root you'd be dealing with. I know from up here that if I cube 3, I get 27. So that kind of tells me that I need to take the cubed root of 27, right? But in order to take the root of something, that why did I not write here? That exponent needs to be in a fractional form. So if we have 27 raised to the 1/3 power, my denominator is my root, and then nope. Yeah, right. You're stupid. I'm sure it's spam because that's like my same phone number. And then your exponent is your numerator, right? So it's just 1. Y'all here, you could either just know that 3 cubed is going to give you 27, or you could use a fundamental theorem of arithmetic, which is also called prime factorization. And you could like pull out certain things if you can. Your goal though would be that it all comes out, right? Because that's how the answer is. But if you needed to do prime factorization or something, you could. I see that 3 times 3 times 3 is 27. So that means, because my root is 3, I'm looking for groups of size 3, okay? And like intermediate algebra right here. Or like I said, you could just know if I do 3 cubed, I get 27. So that means I need to take the cubed root of 27. To take the root, I need my exponent to be in a fraction. Okay, 3 over 3. Does that make sense? I don't even know why I asked because y'all don't answer. Talking to myself. Okay, let's go over these properties, and then you'll take your quiz. And again, literally, you have everything sitting right in front of you. You're going to have a piece of paper. You write your name, today's date, solve these 4 problems. When you're done, you can go. If you want your exam, let me know. Okay. And we'll do this every single class period because these are really easy to mess up. Okay, so let's go over these properties real quick. Well, like in about 10 minutes. Okay, I'm gonna go ahead and write the 2 forms right up here on the top, okay? We've got log base b of a equals x, and we have b to the x equals a. Right, so I've got base, exponent, answer, log of base, answer, equal exponent, right? That's where all those are. So there's properties. And again, these will help like later when you can kind of start noticing them, like it keeps you from having to do work you don't have to do because you recognize a property, okay? One of the properties is that if we have log base b of b, the answer that we would get for this logarithmic problem would be 1. That would actually be the exponent in exponential form. And I'm going to write it that way too. So in exponential form, this is saying b raised to the first power is b. Base raised to the exponent gave me this answer, right? The only way I could start with b and end with b using an exponent is if it was 1, right? So b raised to the first is b. So this is the same thing we've been doing. I just changed the form. So an example of that, y'all, log base 6 of 6 equals 1. And this is because 6 to the first power equals 6, right? Okay, so there's another property that says if we have log base b 1, the answer is 0. And that's because if we have something raised to the 0 power, we get 1, right? So this is saying b to the 0 power gives me 1. Exponential form is saying b to the 0 power gives me 1. So I'm just thinking like later on when we're doing all the equations and this and that, when you see this, your 1 for your answer right here, you automatically know, okay, well, that goes to 0. Or when you see this, you're like, oh, well, that's 1, right? Like that's where these are going to come into play. So y'all, if we had log base 5 of 1, 5 to the 0 power gives you 1. Okay. So another property says if we have this form, right, log base b of b to the x. So I've got my little base b right here, and then like where my a is in this form, it's actually something being raised to a power. Okay, so this, if you ever see this form, the answer is just that power. It's just that exponent. It's just x. And the reason why is because b to the x equals b to the x. Okay, so look at this example. Say we have log base 3 of 3 raised to the 5th power. All right, I said that the answer to this logarithmic form, that's my exponent right here. So that's just 5. And the reason why, y'all, 6 raised to the first power equals 6. 5 raised to the 0 power equals 1. 3 raised to the 5th power equals 3 to the 5th power. Okay? That's why your answer ends up just being that exponent right there. I did another one of these. Log base x of x squared. So what would my answer be there? 2. It's the exponent that's on my, that's actually like my A term right there, right? It would be 2. And this is because x raised to the second power is x raised to the second power, okay? Okay, I need to change pages for our last property. Like a lot of little puzzles. Okay, this one says, okay, so there's a property that says, say we have B. It's kind of like, it's like a big B. It's like a normal B. It's not little or anything. It's being raised. Okay, so in my exponent, I have log another little b of x. So that's b raised to the log base b of x, right? If you have this, if you see this, the answer is just x. So an example of this is like 3 log base 3 of 5. My answer is just 5. So honestly, just if you notice, you've got, it just looks ugly, right? You've got a log and an exponent. In logarithmic form, this is log base b of a, right? So if you see this, whatever your a is here, whatever your normal sized number, not a little subscript, that's your answer. Okay, and then I did same thing, x, but now raised to the log base x 2. And just like really notice that you can clearly tell that's a little x and that's a normal size 2. Okay, when you write these problems, you have to make sure you keep all that clear. That answer would just be 2, right? And that's because I'm just looking at the property and I'm just going to use it. No real thought has to go into these properties if you can get them down. Okay. Like these 2. That is it. I'm going to put the quiz like 4 minutes earlier than my first class, but it's okay. I'm going to put the quiz just right here. Y'all literally just write your name, today's date, problem 1, use your notes. It's 4 problems. The first 2 problems. Okay, so this is going to get grades in the quiz category guide of the grade book, and this counts for your attendance. So I don't have to call roll. I can literally just like, oh, columns here, columns here. You know what I mean? Like that's how it's going to count. Let me turn this off.